rational expressions. So just like we did with all the other operations, let's look at a numerical example first. So a complex fraction is just a fraction that has fractions in it. So for example, 1/2 plus 3/4 over 5/6 minus 3/8. So that is not very conducive to, well, a couple of things. It's not very easy to work with if I want to do operations with it. So like if I want to use that number in any other problem, it's not super easy to work with. And it also doesn't really give me much of an idea what the size of that number is, right? Like most fractions we can look at, like if I look at like 3/8, I can be like, oh, that's a little less than half, right? Because 4/8 is half. But when I look at this expression, like I have no idea what size that number is, so what magnitude it has. And so these are just like not convenient for a few reasons. And so we always, whenever we see a complex fraction or complex rational expression, we always want to simplify it so that we have a single numerator, which is not a fraction, and a single denominator, which is not a fraction. And the way we're going to do that is just using order of operations. So remember that this fraction bar is the same as division. And also that because there's addition and or subtraction, both in this case, in the numerator and denominator, we're going to put the whole thing in parentheses. And so I'm going to rewrite this as a division problem. So we have 1/2 plus 3/4 divided by 5/6 minus 3/8. Those parentheses are really important because as soon as I take the numerator and denominator out of the fraction, then we don't have the fraction bar to group them together. And so if I didn't have these parentheses, the order in which I do these operations would be totally different, right? We would do the division first, which isn't what we want to do because that fraction tells us that the numerator is grouped and the denominator is grouped. And so we need to have those parentheses or else we're saying something totally different than what we really intend to do. So these look somewhat complex. But if you think of them sort of in chunks, they're a little bit more manageable. So you want to think of doing this problem and doing this problem first. So think of it as like two little separate problems before you worry about anything else. So I need to get common denominators here. My LCM is going to be 4. So we have 2/4 plus 3/4, and that's 5/4. And it's totally fine to like do these like one at a time. However, be sure that you keep them like that you don't like go over here and do one of them and then go over here and do another one. It's really easy to put things back together incorrectly if you like try to do them in separate places. So just go straight down and then straight down on the other side, and that way within the larger expression everything stays in the same place. So same thing here, we're going to get common denominators. Looks like my LCM is going to be 24. So we have 5/6 times 4/4 minus 3/8 times 3/3, which will give me 20/24 minus 9/24, which is 11/24. So notice in that last step, I dropped the parentheses, and the reason for that is because I don't have any addition or subtraction to group anymore, right? Now we just have a single fraction divided by a single fraction, which we can do by multiplying by the reciprocal of the divisor. So we have 5/4 times 24/11. So we'll factor. And we can cancel off a couple 2's. And we get 30/11. So now we have a single fraction. We have one number in the numerator, one number in the denominator. So with rational expressions, we're going to take exactly the same approach. Our goal is to have a single polynomial in the numerator and a single polynomial in the denominator. And you can kind of think of it, I kind of think of it as like three separate problems. So the first problem being this guy, the second being this guy, and then the third is where I actually do the division. So if you can kind of break it down into three little problems rather than like, it can be kind of overwhelming looking at it all at once. But if you can think of it sort of as three smaller problems, it's a little easier to approach without getting overwhelmed. So let's throw a couple variables in there. Do you guys understand just the basic idea of what we're doing? So that basic process as far as treating this like a order of operations problem. Does that make sense? Okay. So let's look at a couple more. Let's do, oops, I don't want red. We'll simplify. How about 3/x plus 1/2x divided by 9/4x. So again, we're going to start by thinking of this as division. I have addition in my numerator, and then my division is right here. So we have 3/x plus 1/2x divided by 9/4x. And whether or not you put that 9/4x in parentheses is totally up to you. We technically don't need it because there's no addition or subtraction to group, but if you feel more comfortable kind of separating them in that way, you can go for it. So I'm just going to start in the parentheses on the left. The rest of the problem is just going to come along for the ride. So it looks like my LCM is going to be 2x. So I'm going to multiply by 2/2. And then I'm just rewriting this divided by 4x because I don't have to do anything with that until I'm ready to divide. So I have 6/2x plus 1/2x. Gives me 7/2x divided by 9/4x. So now we're ready to do the division. So I'm going to multiply 7/2x by the reciprocal of my divisor, so 4x/9. And we don't really have to do a ton of factoring to see what's going on here, although you can definitely do the prime factorization if you want. We see that there's a factor of x that cancels, right? And then a factor of 2. Everybody see that? So we end up with 14 over 9. Let's do this one. That one okay with everybody? Not too bad. Okay. This is one of those things that looks worse than it is. If you like stay calm and just do your the pieces, then it's not too awful. They just can look pretty intimidating because they're kind of messy. That's why they're called complex. So let's simplify. Whoa. We'll do 1 minus 1 over x divided by 1 minus 1 over x squared. What? It's not 1. No.
6.
No. Well, you can't cancel terms, right? So we group our addition, well, in this case, it's just subtraction. And then we have our division right here. So we've got 1 minus 1 over x divided by 1 minus 1 over x squared. So I'll just start with that subtraction problem on the left. I need to get common denominators. If you learn nothing else about fractions, that one of the most useful things to know about fractions is that any fraction that's the same on the top and the bottom is equal to 1. So if you see the number 1 and you want to write it as a fraction with a certain denominator, you just put that denominator over itself. So like here I want a common denominator of x, and so I'm going to rewrite that 1 as x divided by x. You can write the number 1 as a fraction with any denominator you want. It just has to be the same on the top and the bottom because anything divided by itself is 1. And so this gives me x minus 1 over x. And then we're going to do the same thing here. I want my denominator to be x squared, so how should I write the number 1?
X squared over x squared?
Mm-hmm. So we end up with x squared minus 1 over x squared. And then again, we're in a situation where we have some fractions. There's addition, subtraction in those fractions. So remember, this is a single factor. This is a single factor. We can't cancel anything that's involved in addition or subtraction. So we'll rewrite this as multiplication.
Would we factor that x squared minus 1?
Yes, we will. I'm going to write it as multiplication first. And then, yes, to simplify this, we have to factor. So in this case, the only thing that factors is that x squared minus 1. So we have x minus 1 times x squared over x times x minus 1 times x plus 1. And that's just the factorization of x squared minus 1. So I'm going to cancel an x minus 1, and I'm going to cancel one factor of x. So I end up with a single factor of x in the numerator, and then x plus 1 in the denominator. You guys ready to try one? These problems are kind of nice because they kind of incorporate everything we've done this week, right? So you get a chance to think about what you how you actually do each operation, right? One of the common sources of misery with these is when people try to get common denominators to like multiply or divide. I mean, you could get common denominators when you multiply, but you're just going to end up canceling a whole lot of stuff. So you just make it like 10 times messier than you need to. So the only time we need common denominators is when we are adding or subtracting. Remember, when we multiply, we're just kind of smushing everything together and then factoring so that we can cancel. But you don't need common denominators to multiply or divide. Multiplying and dividing is really just like simplifying. We factor and cancel. So the only time you need those common denominators is when you're adding or subtracting. So within those parentheses, you might get common denominators. But then once we get down here to the part where we're multiplying, all we need to do is factor. So let's do x over 2 plus 2x over 3 1 over x minus x over 2. Give that one a shot. So we have 2 over 2x minus x squared over 2x. The place where we want to be really careful to be aware of what operations are going on, right? We're subtracting, and so the numerator is going to be 2 minus x squared. And then over 2x. Like, it would be more convenient if that was 2x squared, but it's just not because we're subtracting, right? What?
Oh, never mind.
Good?
You haven't flipped yet. Okay.
So now we're going to multiply by the reciprocal. So 2x over 2 minus x squared. And the only thing that cancels here is this 2. So we end up with 7x squared over 3 times 2 minus x squared. If I didn't know that 2 minus x squared doesn't factor, then I would certainly go over here and be like, okay, I want to factor this, so I'm going to put it in descending order, factor out a -1. But there's not any number that multiplies to -2 and adds to 0, right? Because the only factors that multiply to 2 are 2 and 1. So there's no way I'm going to get those guys to add to 0. And so this isn't going to factor anymore. So like, your answer could be 7x squared over -3 times x squared minus 2, depending on if you like tried to factor in the denominator. And so you got that factor of -1. So either one of these would be acceptable. So if you got that first one and didn't know just off the top of your head that 2 minus x squared doesn't factor, then you'd go ahead and try to factor it and you'd end up with the second one. But either one is fine. And just remember, like, that general rule that when you have addition or subtraction in the numerator or denominator of a fraction, that is automatically grouped as a single factor. So we can't do anything with the 2 or the x squared within that factor. I think that's what I saw as I was walking around. Any questions? Anybody get anything different?
I got 7/6, but that's because I did some stuff wrong.
I did the same thing. I did the LCMs and canceled.
Well, so if you got 7/6, you probably canceled terms within that factor. So again, you want to, as soon as you get addition or subtraction, put those parentheses around it. That's going to help you remember that that's a single factor, right? And that we can't do anything with the individual terms within it. One of the keys to really everything we do is differentiating between like what operations are going on. So if we're multiplying, if we're adding, subtracting. So because things behave differently when you're adding and subtracting them than they do when you're multiplying them, right? So we want to keep in mind that the only way that we can cancel anything is if it's involved only in multiplication. So if the entire numerator is factored, the entire denominator is factored. Okay, let's look at one more example and then let you guys work on your homework a little bit. Your homework's pretty short tonight. I think there's only 4 problems. So we will simplify 3 over x plus 1 plus 1 over x divided by 2 over x plus 1 plus 3 over x. So again, we want to be really, really careful with what operations are happening here. So this entire thing is grouped, right? Because there's addition there. But within that, we have fractions that have addition, subtraction in them. So we want to be really careful about finding our LCM when we get to that point. So let's rewrite first. Plus 1 plus 1 over x divided by 2 over x plus 1 plus 3 over x. So in that first set of parentheses, what is my LCM going to be?
1.
Just 1?
Or x plus 1?
Okay, what do you multiply x by to get x plus 1?
1.
But 1 times x is x.
Yeah. So the LCM is x and then x plus 1.
Yeah, it's x times x plus 1, right? We have 2 factors, x plus 1 and x. Because there's nothing you can multiply x by to get x plus 1, right? That would be like having denominators of like 5 and 4, or like 6 and 5, right? Because one of them is just one more than the other. You can't get one more than a number through multiplication. So we're going to multiply by x over x. And then by x plus 1 over x plus 1. And that's another reason for those parentheses, is if I have something in parentheses like that x plus 1, it is a different factor than anything else. So it's a different factor than x. If there was something that I could multiply x by to get x plus 1, then I'd be able to write x plus 1 as x times something else. So I wouldn't need parentheses around that whole thing as a single factor. So here we have 3x plus 1 times x plus 1 over x times x plus 1. So that's 3x plus x plus 1. Which gives me 4x plus 1 over x times x plus 1. And I'm going to immediately put this 4x plus 1 in parentheses so that I am not tempted to do anything illegal.
Why wouldn't the x plus 1 after the 3x be in parentheses?
This right here?
Yeah.
Because I distributed that 1.
Okay.
So I don't need parentheses anymore. So now let's do the same thing with the second fraction. So with that divisor, I'm going to have you guys do that one. So in the second set of parentheses, get common denominators and do that addition. So anything, right? Because there's that addition outside of the parentheses on the top. So we have to keep going to simplify that numerator. So we'll distribute and combine like terms. And as soon as I see that there's addition in my numerator, I'm going to put that in parentheses before I start trying to cancel things. Come all the way up here. So then we have 4x plus 1. And this thing with the parentheses is like, so one thing I notice is you guys, sometimes you'll write the parentheses in one step, but then like drop them in the next step. So we want to keep those throughout the whole thing. The only time you're going to get rid of parentheses is when you like distribute to get rid of them. So when you're simplifying. But since at this point we're factoring the numerator and denominator, we might, when you factor, you might create more sets of parentheses, but you never get rid of them because you're not doing any distributing to factor. So we only distribute when we are simplifying. So once we get to this point, you don't want to drop any parentheses. Over 5x plus 3. So the nice thing about the fact that we have the same LCM in both the numerator and denominator is that whole thing just cancels when we divide. So we're going to end up with 4x plus 1 over 5x plus 3. You can keep the parentheses. I am perfectly happy for you to do that. Just to be extra careful. In this case, you don't need them because neither is being multiplied by anything. So in that final answer, you can drop the parentheses as long as you don't try to then cancel things. As long as it's just for your final answer. But my math lab will accept it, and I will accept it just as well if you keep the parentheses there. Any questions? So I want to give you some time to practice this, because that's really the best way to get more comfortable with it, is to just do enough that it doesn't feel too over.